Hi, we're back with more trigonometry, just basic trigonometry, SOHCAHTOA. The question here says, work out the missing side x and give your answer to one decimal place or better. But in all of these questions, we have to look and we have to search and we have to see where is the right-angled triangle they're talking about. You have to analyze the question and see, where can I see my right-angled triangle? So let's look at the second one here. So this is a rectangle. We need to analyze the problem. We are looking for x. They've given us 15, and they've given us this 58 degrees, but we need to say, well, where is the right-angled triangle that we're looking for? Let's just have a look. I found it here. This is the one we're interested in, that right-angled triangle. The only problem is we don't have any angles to help us solve the problem. We need to find either this angle or that angle. Now, if we look across from 58, vertically opposite 58 is going to be identical to that. So this will also be 58. Okay? So we are looking at an isosceles triangle, okay, with this value being 58. These two have to be equal because this is an isosceles triangle. Okay? So what we need to do is take 180, subtract that 58, and then divide that into the remaining two sides. So those two will be 61 degrees. Okay? Now that 61 is identical to this angle here. Okay? Let's go on to the next page. So we found our right-angled triangle. Now we use trigonometry to solve for the unknown side x. With respect to 61 degrees, x is the opposite side. Okay, x is the opposite side. And 15 is the adjacent side. Okay. So with opposite and adjacent, which one do we use? Opposite and adjacent. There it is, tan. Tan is the opposite over adjacent. Okay, so we're going to be using tan. Substitute in your values. X equals 61. Well, in this case, this value is 61. X is actually the opposite side, and 15 is the adjacent side. To rearrange this, you multiply by 15 on both sides. So you end up with 15 tan 61. Type that directly into your calculator to get 27.60. The question asks you to round to one decimal place. So this is going to be 27.1 centimeters. Okay? That's that question. Again, with these harder questions, you've got to analyze the problem to figure out what they're asking you. The next one we're going to do is the third one here. Okay. Now this one, there's two triangles to consider in this one. There's some information that you need to read though. ABC is right angled, okay, and AD, the line from A to D, is the bisector of angle BAC. So here's angle BAC, and this line bisects the angle. So that means that this 16 degrees, then this will also be 16 degrees because it cuts the angle in half. Okay, so we have 16 degrees and then 16 degrees down here. So this one is going to be 16 degrees. Okay, this 28 centimeters on the bottom and 16 degrees. I've called this length y. Okay, and this big right-angled triangle will have a 32-degree angle, 16 times 2. Okay. And I've called that length, the whole length, z. So this big z, if I subtract off that little y there, my result is going to be what we're after, which is x. So we have to deal with two right-angled triangles. They both have opposite. The opposite of 32 is z, and adjacent. So we're going to be using tan again. Opposite over adjacent. So the tan of 32 is the opposite, z, divided by the adjacent, which is 28. So So our value of z is 28 times tan 32. We'll get to that answer in a moment. Same thing, we have the exact same situation here. So we're going to have the tan of 16 this time equals y over 28. Multiply by 28 on both sides, and you get 28 tan 16. Okay. Now we have this length and we have that length. To get x, we now subtract the two. Okay, and you can type that directly into your calculator. And the result is 9.467. Rounding to 1 decimal place, we get 9.5. Okay? So, we answered those two. See if you can find the right-angled triangle hidden in this one, and use trigonometry to solve for x. Okay? And here are all the answers. Thank you very much. Bye.